Chapter 1. Units and Measurements. Exercises pages 14 to 15. Exercises Q1. Page 14. Choose the correct option. L1m1t1 is the dimensional formula for 1. Velocity 2. Acceleration 3. Force 4. Work. Solution. L1m1t1 is the dimensional formula for force. Exercises Q1. Page 14. Choose the correct option. The error in the measurement of the sides of a rectangle is 1%. The error in the measurement of its area is. Solution. The error in the measurement of the sides of a rectangle is 1%. The error in the measurement of its area is 2%. Explanation. Exercises Q1. Page 14. Choose the correct option. A light year is a unit of underscore 1. Time 2. Mass 3. Distance 4. Luminosity. Solution. A light year is a unit of distance. Exercises Q1. IV page 14. Choose the correct option. Dimensions of kinetic energy are the same as that of underscore 1. Force 2. Acceleration 3. Work 4. Pressure. Solution. Dimensions of kinetic energy are the same as that of work. Exercises Q1. Page 14. Choose the correct option. Which of the following is not a fundamental unit? 1. cm 2. Kilogram 3. Centigrade 4. Volt. Solution. Volt. Exercises Q2. Page 14. Answer the following question. Star A is farther than star B. Which star will have a large parallax angle? Solution. Exercises Q2. Page 14. Answer the following question. What are the dimensions of the quantity? Being the length, and g the acceleration due to gravity. Solution. Exercises Q2. Page 14. Define absolute error. Solution. 1. For a given set of measurements of a quantity, the magnitude of the difference between mean value, most probable value, and each individual value is called absolute error, delta A, in the measurement of that quantity. Exercises Q2. Page 14. Define mean absolute error. Solution. For a given set of measurements of the same quantity, the arithmetic mean of all the absolute errors is called mean absolute error in the measurement of that physical quantity. Exercises Q2. Page 14. Define mean percentage error. Solution. The relative error represented by percentage, i.e., multiplied by 100, is called the percentage error. Exercises Q2. IV page 14. Answer the following question. Describe what is meant by significant figures in order of magnitude. Solution. 1. Significant figures in the measured value of a physical quantity is the sum of reliable digits and the first uncertain digit. O are the number of digits in a measurement about which we are certain, plus one additional digit. The first one about which we are not certain is known as significant figures or significant digits. 2. The larger the number of significant figures obtained in a measurement, the greater is the accuracy of the measurement. The reverse is also true. 3. If one uses the instrument of small or least count, the number of significant digits increases. Rules for determining significant figures. 1. All the non-zero digits are significant. For example, if the volume of an object is 178.43 cc, there are 5 significant digits which are 1, 7, 8, 4 and 3. 2. All the zeros between two non-zero digits are significant, e.g., m equals 165.02 grams has 5 significant digits. 3. If the number is less than 1, the zeros on the right of the decimal point and to the left of the first non-zero digit are not significant, e.g. in 0.001405, the underlined zeros are not significant. Thus the above number has 4 significant digits. 4. The zeros on the right-hand side of the last non-zero number are significant, but for this, the number must be written with a decimal point, e.g. 1.500 or 0.01500. Both have 4 significant figures each. On the contrary, if a measurement yields length L given as L equals 125 meters equals 12,500 centimeters equals 125,000 millimeters, it has only 3 significant digits. Exercises Q2. B. Page 14. Answer the following question. If the measured values of the two quantities are A plus or minus delta A and B plus or minus delta B, delta A and delta B being the mean absolute errors, what is the maximum possible error in A plus or minus B? Solution. The maximum possible error in A plus or minus B is delta A plus delta B. Solution. Errors in divisions. Thus, when two quantities are divided, the maximum relative error in the result is the sum of relative errors in each quantity. Exercises Q2. B. Page 14. Answer the following question. Derive the formula of the kinetic energy of a particle having mass, m, and velocity, v, using dimensional analysis. Solution. The kinetic energy of a body depends upon mass, m, and velocity, v, of the body. Let Ke proportional mx vy. Therefore Ke equals kmx vy. 1. Where K equals dimensionless constant of proportionality. Taking dimensions on both sides of equation 1. Exercises Q3. I. Page 14. Solve the numerical example. The masses of two bodies are measured to be 15.7 plus or minus 0.2 kilograms and 27.3 plus or minus 0.3 kilograms. What is the total mass of the two and the error in it? Solution. Given A plus or minus delta A equals 15.7 plus or minus 0.2 kilograms and B plus or minus delta B equals 27.3 plus or minus 0.3 kilogram. To find total mass Z and total error delta Z. Formulae. I. Z equals A plus BE. Plus or minus. Delta Z equals plus or minus delta A plus or minus delta B. Calculation. From formula I. Z equals 15.7 plus 27.3 equals 43 kilograms. From formula E. Plus or minus delta Z equals plus or minus 0.2 plus or minus 0.3. Equals plus or minus 0.2 plus 0.3. Equals plus or minus 0.5 kilograms. Total mass is 43 kilograms and total error is plus or minus 0.5 kilograms. Exercises Q3. E. Page 14. Solve the numerical example. The distance traveled by an object in time, 100 plus or minus 1 s is 5.2 plus or minus 0.1 m. What are the speed and its maximum relative error? Solution. Exercises Q3. IV. Page 14. Solve the numerical example. A large ball 2 meters in radius is made up of a rope of square cross-section with edge length 4 millimeters. Neglecting the air gaps in the ball, what is the total length of the rope to the nearest order of magnitude? Solution. Exercises Q3. B. Page 14. Solve the numerical example. Nuclear radius r has a dependence on the mass number A, as r equals 1.3 times 10 to 16 a 1/3 of a meter. For a nucleus of mass number A equals 125, obtain the order of magnitude of r expressed in the meter. Solution. R equals 1.3 times 10 to 16 times a 1/3 of a meter. For A equals 125, R equals 1.3 times 10 to 16 times 12513. Equals 1.3 times 10 to 16 times 5313. Equals 1.3 times 10 to 16 times 5. Equals 6.5 times 10 to 16. Equals 0.65 times 10 minus 15 meters. Therefore order of magnitude equals 15. Exercises Q3. B. Page 14. Solve the numerical example. In a workshop, a worker measures the length of a steel plate with vernier calipers having a least count 0.01 centimeters. 4 such measurements of the length yielded the following values. 3.11 centimeters, 3.13 centimeters, 3.14 centimeters, 3.14 centimeters. Find the mean length, the mean absolute error, and the percentage error in the measured value of the length. Solution. Exercises Q3. B. Page 14. Solve the numerical example. Find the percentage error in kinetic energy of a body having mass 60.0 plus or minus 0.3 grams moving with a velocity of 25.0 plus or minus 0.1 centimeters per second. Solution. Exercises Q3. B. Page 15. Solve the numerical example. In Ohm's experiments, the values of the unknown resistances were found to be 6.12 ohms, 6.09 ohms, 6.22 ohms, 6.15 ohms. Calculate the mean absolute error, relative error, and percentage error in these measurements. Solution. Exercises Q3. X page 15. Solve the numerical example. An object is falling freely under the gravitational force. Its velocity after traveling a distance h is v. If versus depends upon gravitational acceleration g and distance, prove with the dimensional analysis that v equals square root gh where k is a constant. Solution. Exercises Q3. X page 15. Solve the numerical example. Is a dimensionally valid equation. Obtain the dimensional formula for A, B and C where versus is velocity, t is time and v0 is initial velocity. Solution. As only dimensionally identical quantities can be added together or subtracted from each other, each term on RHS has dimensions of LHS, i.e., dimensions of velocity. Exercises Q3. Sheet page 15. Solve the numerical example. The length, breadth and thickness of a rectangular sheet of metal are 4.234 meters, 1.005 meters and 2.01 centimeters respectively. Give the area and volume of the sheet to correct significant figures. Solution. Given L equals 4.234 meters, B equals 1.005 meters, T equals 2.01 centimeters equals 2.01 times 10 to 2 m equals 0.0201 meters. To find I. Area of sheet to correct significant figures A. E. Volume of sheet to correct significant figures B. Formulae. 1. A equals 2 LV plus VT plus TL. 2. V equals L times B times T. Calculation. From formula I. A equals 4.234 times 1.005 plus 1.005 times 0.0201 plus 0.0201 times 4.234. Equals to antilog log 4.234 plus log 1.005 plus antilog log 1.005 plus log 0.0201 plus antilog log 0.0201 plus log 4.234. Exercises Q3. Sheet page 15. Solve the numerical example. If the length of a cylinder is L equals 4.00 plus or minus 0.001 cm, radius R equals 0.0250 plus or minus 0.001 cm and mass M equals 6.25 plus or minus 0.01 g. Calculate the percentage error in the determination of density. Solution. Given L equals 4.00 plus or minus 0.001 cm. In order to have same precision, we use 4.000 plus or minus 0.001 R equals 0.0250 plus or minus 0.001 cm. In order to have same precision, we use 0.025 plus or minus 0.001 m equals 6.25 plus or minus 0.01 g. To find percentage error in density. Formulae. Exercises Q3. Sheet page 15. Solve the numerical example. When the planet Jupiter is at a distance of 824.7 million kilometers from the Earth, its angular diameter is measured to be 35.72 inches of arc. Calculate the diameter of Jupiter. Solution. Given angular diameter alpha equals 35.72 inches equals 35.72 inches times 4.847 times 10⁻6 radians. Approximately equals 1.73 times 10⁻4 radians. Distance from Earth D equals 824.7 million kilometers. Equals 824.7 times 106 kilometers. Equals 824.7 times 109 meters. To find diameter of Jupiter D. Formula. D equals alpha D. Calculation. From the formula, D equals 1.73 times 10 to 4 times 824.7 times 109. Equals 1.428 times 108 meters. Equals 1.428 times 105 kilometers. The diameter of Jupiter is 1.428 times 105 kilometers. Exercises Q3. XIV, page 15. Solve the numerical example. If the formula for a physical quantity is x equals, and if the percentage error in the measurements of A, B, C and D are 2%, 3%, 3% and 4% respectively. Calculate percentage error in X. Solution. Exercises Q3. XV, page 15. Solve the numerical example. Write down the number of significant figures in the following. 0.003 square meters, 0.1250 gmcm2, 6.4 by 106 meters, 1.6 x 10 to 19 c, 9.1 x 10 to 31 kilogram. Solution. Number. No of significant figures. Reason. 0.003 square meters. 1. Rule no E. 0.1250 grams cm2. 4. Rule no IV. 6.4 times 106 meters. 2. Rule no I. 1.6 times 10 to 19 c. 2. Rule no I. 9.1 times 10⁻31 kilograms. 2. Rule no I. Exercises Q3. XVI, page 15. Solve the numerical example. The diameter of a sphere is 2.14 centimeters. Calculate the volume of the sphere to the correct number of significant figures. Solution. In multiplication or division, the final result should retain as many significant figures as there are in the original number with the least significant figures. Therefore, volume in correct significant figures equals 5.13 cc.
Make it